Hello again. You made it to the third module where we're going to write UI tests using Pylenium and Pytest. Let's jump right in because we're going to code quite a bit. We'll start by taking a look at the demo app we'll be using in this course. It's a simple to-do app with a single view, and this is the URL. Don't worry, I'll include it in the notes below too. For now, the scenarios we want to cover will be checking the first item on the list, checking many items on the list, checking all items on the list, adding a new item to the list, and if we can, remove an item from the list as well. I'll open the website and, sure enough, it's super basic. But the focus of this course isn't so much Python programming or page objects, so this will do just fine. With that, let's write the first test against our app, which is to check the first item. With our project open in VS Code, the first thing I need to do is create a new file. So under tests, let's make one called test_todo.py. Let's put our tests against this to-do app in this file for now. All right, so let's start it off with Pylenium driver, bringing that in. Import Pylenium. All right, and the name of our first test is going to be test check first item. Now that the test signature is done, let's get to the website. And I probably should have copied this because this is kind of a long one, but that's okay. Sample to do app. Bada bing, bada boom. Okay, next I need to get to the checkbox, and then I need to click the checkbox. I'm just going to put click it, and then I need to assert that it's checked. So let's work on step 2 here, which is getting the checkbox. Open our developer tools, and I'm going to find this first item checkbox. And here we go on this side. So we see that we have this input, which is the checkbox itself right here, but it's under this li, this list item of ng repeat sample to do, and then also has the span with the name first item. Now, there's a few different ways we can find this actually. We could do it by position, right? We could find all the li elements and say, give me the first item in here. We could also do it by the name of the item. So in this case, it would just be called first item. And I'm going to go with that one because I like the flexibility of finding things by name more so than just position. Especially since I know that in our future scenarios, we will need to find things by name, not really by position. So let's see if we can find that. Anytime you want to work with text of an element, it's usually best to work with XPath. So let's see if we can find this. All right, and here we'll have the text that equals first item, exactly how it's spelled there. And there we go. Sure enough, we found it. So I have it, but the only problem is that I don't think I can actually click on this thing. It's just a span element. So let's find out. If I click this, does it do anything? Nope, nothing changed. So I'm close because I have the span element, but I want its like previous sibling, right? I want this one right here. And so for now, I think what I'll do is just, I can have the parent element, and then, because that would be the li itself. If I click on that, that probably doesn't work either. Yep, I definitely got to click on the input element. So, which is definitely okay. If we say query selector here, and I just say input, which would be the child, right? And get the input. There it is. And exactly what we want. Click on it, and it got checked. Let's go. So I was able to find it by text, then get its parent, and then from the parent get the input. And again, there's lots and lots of ways of finding this one. You could even use things like previous sibling and whatnot. But for now, I'm going to keep it like this, just so then you can see how this would look like inside of Pylenium. So before I move over, I'm going to copy this XPath because this is exactly what I wanted. I don't have to repeat myself, right? So copy this and let's switch back over to code. Okay, so checking the box. Let's say checkbox is equal to py.getX, which would be XPath. And then I'm just going to paste what I had copied. There we go. From there, we got the parent, and then we got the input. Not too shabby, huh? All right, next up is clicking the checkbox. And so we have it already, checkbox.click. And that's done. Now let's assert that the checkbox should be checked. So assert that the checkbox should be checked. Sweet. And there you have it. The first test is done. So now on to the second one. I'm going to get rid of these comment lines here. They were just helpful for me in my thinking as I was doing stuff. For the next test, it would be test check many items, right? And we'll use the same stuff that we had before. And Rutrow, I just realized I have to do the exact same thing. So let me grab this line, come back down here, paste it in there. And now for test check many items, we immediately see duplicated code with the py.visit in both tests, right? But we'll clean that up later. I just want to note it because already we're copying and pasting code, which usually is a sign that we could optimize it a little bit better. But let's keep going. So for checking many items, I think let's just do at least 2 of them. So we already took care of the first item. Let's click on like the second and fourth item, let's say. All right, so let's grab these 2 and check them. Now this is something that where the positions would make sense, right? Because I don't really care about their name. I just care about their position. And so, okay, we'll have to change our strategy here a little bit, not find things by text, but find things by position. So let's see how we can do that. Now in here, I want to grab a list of these things. And fortunately, they're already in a list with these LIs, right? The LI sample to do. So let's see if we can use that. So in this case, I'm going to do $$, which is now a jQuery or CSS selector. And let's find all of the LI elements that have the ng repeat that contains the ng repeat of sample to do. This is something like that. Now there's 5 of these things, which would make sense, right? And if I expand this list here and go through them, 1, 2, 3, 4, and 5. Okay, so if I want to click on the second item here, then we would index 1, right? Because 1 would be the second item. 0 would be the first item. Right on. So we have this. I'm going to copy this and switch back over to our code. So let's start by making a variable. I'm going to call it to-dos. And then I want to not get a single element. I want to find many of them. So py.find and paste in my CSS selector. But we want to grab the to-do number 2 and to-do number 4. Right? So to-do 2 and to-do 4, this would be equal to to-dos with the index of 1, right? And then to-dos with the index of 3. Now that we have to-do 2 and to-do 4, we just got to click on each one. So to-do 2 dot click, well, no, because remember, we need to get the input element. And right now we have the li ng repeat thing. And so we need to say to-do2.get the input and click on that. And then to-do4.get the input and click on that one. All right, and what happens when we click on these 2 things? So if I click on second item and fourth item, this changes, right? It now says 3 of 5 remaining, which makes a whole lot of sense. Could we use this text to actually do our assertion here? Let me inspect it real quick. And yeah, sure enough, there's text saying 3 of 5 remaining. So let me give that a try real quick. Let me switch back over to code here. And let's assert that somewhere on the page it says 3 of 5 remaining. So assert py contains 3 of 5 remaining. And that's it, y'all. How you like them apples? See, it's pretty clear, and the test itself reads really, really well. But even with it looking as nice as it does so far, we do have a few problems actually, right? One of them was that we copied and pasted py.visit. Any new test we add, we're gonna have to do the same thing, right? Which is not ideal. The other thing too is that lines 15 and 16 here, where we did the to-do get input and to-do4.get input, was a little spicy too, right? So I wonder if we can clean this up. So I'd like to take some time to refactor our tests, since we're going to start repeating ourselves quite a bit. I'm going to have us build something that's going to basically look like a page object, and that's fine. So here, let's create a class that's called toDoPage that's going to represent this page. So def init self Pylenium. And this is, you can think of the def init as kind of like a constructor. It's not exactly a constructor, but it's essentially doing the same thing. So if you're familiar with like Java or C#, hopefully this is already making sense for you. But if not, that's a-okay as well. So we're going to initialize the to-do page. You have to pass in the web driver, which is Pylenium here. And let's make a function called goTo, which is going to do the py.visit part. So let me grab this part again here and copy all this goodness. So copy right in here. We're going to paste a Ruski. You'll see at the beginning the py is green, and that's because we're inside of a class now. So we have to say self.py.visit. And then I'm going to return self. Now, why return self? Well, the reason why we're returning self is because when I go to the to-do page and use this function goTo, I'm still on the to-do page. There are going to be some functions that when you call them, they take you to a different page. So don't return self, you're on a new page, so return the new page instead, right? You might see this return self in action a little bit later, but for now, just add that in there, make sure you include it. The next method that we have is to get a to-do by name. So let's say get to-do by name. We have self because we're in a class, and then you pass in the name of the to-do and it will find that element. All right, and for this one, we want to return self.py.getX with whatever element we find that has the text that equals that name that you pass in, and then get the parent back. So this is almost looking exactly like what we had in our test, right? Down here we had get the element by this text of first item, but this would only ever work for this element of first item. So this one is a lot more dynamic, where we can pass in any name and it will find the element and return the parent. Pretty sweet, right? This is green right now because it has no idea what we're talking about. Element doesn't exist anywhere here in this file, but luckily VS Code is super smart. We can click on this here and it says, hey, I think you actually want to import element from Pylenium, which is true. So let's do the second one. Add import element from pylenium.element. And it gets automatically imported for us at the top of the file, and the green squiggly goes away. Very nice. On to the next one. Here, we'll write our last method to get all the to-dos that exist on the page. So instead of returning a single element, this is going to be returning a list of elements. And we can basically copy this part that we already did here, because this is what we're wanting, right? Py.find all this goodness. So let me copy that, go back up here, and then return self dot and paste in what I had there. Just like we had before, elements is green and squiggly because it's not up here yet. And so this time I'm just going to add it manually myself. There's elements, and we see that error go away. Now that we've refactored the logic into something a lot more reusable, we got to set up a Pytest fixture, which acts like a hook, which is just before each and after each. So in other frameworks like a JUnit or an NUnit from Java and C#, you have this like after each do this thing or before each test do this thing. In Pytest, we use the concept of fixtures, which are the exact same thing. It's a single function that works as a before each and an after each. So let's do that right now. At the very top of the file, I'm going to import Pytest. Okay, and then below our to-do, we're going to create a fixture using Pytest, so pytest.fixture, and in here we create a function that will represent our page. So Pylenium, and then return a new instance of our to-do page after we go to it. So a way to think about it is whenever one of our tests uses this page fixture, it's going to go to the to-do page, which navigates to this URL, and then it's going to return an instance of the to-do page for the test to use. Pretty cool, right? So let's go to our first test here because there's going to be quite a bit of refactoring. Let's grab this Pylenium stuff because we don't actually need this anymore. We just need an instance of our page fixture. And we know that our page fixture returns an instance of to-do page. We don't need this first line of py.visit because we're already on the to-do page once this fixture is done, right? So I don't need that line anymore. For the checkbox, we don't need this py.getX or anything because we already have this line in our to-do page. So I can just say page.getToDo by name. And the one that we want is called first item. But we still right now got to get the input. This line remains the same because we still want to check it. And then we're going to assert that it's checked. So the first test has been refactored and cleaned up. Moving to the second one, we do still need Pylenium, so let's leave that alone, but we can still take advantage of our new page fixture, which is just a to-do page. We don't need this first line like we all know, and this py.find, we don't need either. We can actually just say page.getAllToDos, because that returns, well, all the to-dos. And with that, this one is complete as well. It's looking a whole lot better, but I'm still not liking the part where we got to say like todo2.getInput. Still not liking that. Let's write one more test and let's get back to it. For the third test, we are checking all items. So check all items. We have Pylenium that we can take advantage of. We also have our page fixture that we can take advantage of. And now all we got to do here is basically create a for loop and just say, okay, for each one of these items on here, I want to click it, click it, click it, click it, click it, right? And then we should see 0, 5 remaining. That's kind of the gist of this test. So we have all the to-dos already, so I don't got to find anything else, right? We did that. So let's create a for loop to handle that logic for us. So for each to-do in page.getAllToDos, todo.getInput, the part that feels bad, and then we'll click on it. All right, and then from there, we can assert that py.contains config. No, I want py.contains, I said. We want it to be 0 of 5 remaining. And this one is done here too. Okay, in all three tests, we've had to do this .getInput thing because we're dealing with the parent, the li element, and not the input or the checkbox itself. So I think this is a good design decision where what if we had our functions in our to-do page return the input checkbox instead of the parent element? We can do that too. And that might make things look a little bit nicer. So let's go back up here. And instead of this just returning the parent, let's have this actually return the input. So add get input here, that'll take care of that one. And then for our get all to-dos, we just need to say, hey, find the children that are the input. And this one should be taken care of as well. Now we'll go down here. We don't need this get input anymore. So go to these ones over here too. I don't need this. It'll just be to do to.click and to do for .click as well. And then down here, just to do .click. Yeah, that looks a whole lot better, don't you think? I like that more. All right, for the fourth scenario, we now want to add a new item. And we kind of have the logic there already, or the to-do page to do this. So let's go back up here. I feel like I'm saying to do like a million times, but let's do this thing. So inside of our class, let's make a new method that's just called add to do. Self, we want to name it something, right? And we're going to return the to-do page just because, again, when we add a to-do, we're still on the to-do page. It's like going back over here to our application. If I add foo and then add the item, we are still on this to-do page. So I'm going to return the to-do page, right? So when we did that, we interacted with two elements. We needed to add one here and we needed to click this as well. So let's find these things. So inspect it. Here's the input. It has the ID of sample to do text. That's very nice. I'm going to copy that and switch back over to code. Okay, so self.py.get. And let's use the hashtag, which means ID of this. And I want to type in whatever name I pass in. We now need to find the add button. Let's inspect this one here, inspect. And oh, sure enough, the ID is add button. That's very convenient. Thank you, LambdaTest. So simple. And all right. Self.py.get, the hashtag again for ID. And we're going to click it. Then return self, and bada bing, bada boom, our method for adding a to-do is complete. So it shouldn't be too bad for us to now write a test for this because we have all the pieces we need already. Dev test, add new item. We'll be using Pylenium. We'll also be using our to-do page. First thing we'll do is we're going to add a to-do, and let's put it finish the course. Woo! Our first to-do item. And then once we add a to-do, we want to check a few things, right? So once we add this one, one thing that we saw was that, hey, look, the number of remaining went from 5 to 6. So we can actually check that it would say 6 of 6 remaining, and we can also check that there's 6 items in the list, right? 1, 2, 3, 4, 5, and 6. So we can check these two things. We're going to add 2 assertions here. So for the first one, let's say assert page.getAllToDos. This should have the length of 6. For our second assertion, we can say that Py should contain 6 of 6 remaining. And now this one is done. The last scenario we had was to remove an item, but as you saw in the UI, there's not a way for us to remove that item. But I bet that if there was, you would know exactly how to write that test. You would know what to add here to this to-do page class. You'd probably write a method called like def remove to-do by name or remove to-do by position, and then writing the test would be a piece of cake. And this is one of my favorite reasons for using Python, because Python is such a powerful and dynamic language, and you saw how Python, Pytest, and Pylenium, the 3 of them, make such a powerful framework that you get to work in, and writing these tests didn't take much time for us at all. So I hope you enjoyed this. We'll be moving on to the next video, where we'll be running tests in parallel. So I'll see you there.